Good morning. Welcome to lecture 20 of thermodynamics of materials. Last day we are discussing the relationship between Cp and Cv through the expression of Cp minus Cv. So Cp minus Cv last class refer to the last class. What is that? I tell you, Cp minus Cv is P plus del U del V at constant temperature times del V del T at constant pressure. This was our relation. This is the general relationship. General why? Applicable to all systems. Applicable to all systems. All systems, including ideal gas. System like say solid, e.g. solids, liquid, real gases and ideal gas. This is your all systems. Single substance, any given substance, maybe solid, maybe liquid, maybe gas, vapor, and with real behavior or ideal behavior. So this I explained yesterday. Just recall this. First term refers to PdV. Okay, a nice explanation from the first law. Recall. Often I say recall means it is already discussed. Anytime I say recall means it is discussed. It has been discussed. So no difficulty following. Just I actually okay. What is this? Alert you this about this. Recall dq is du plus dw. So since Cp and Cv is about the heat required to raise the temperature of a body through 1 degree. So it is about heat, means this. So this actually has two components, du component and dw component. The first term PdV is the dw. Means P is the external pressure, as I told you. External pressure, this figure I showed. So work done. These are available in Cp. Means heating in a constant pressure system, which is not available, which is not possible in constant volume because there is no work done. No increase in volume. And increase in volume covers two things, involves two things. One is, of course, the work itself. Increase in volume, PdV, in the form of PdV. Just quickly, not bad. But actually here maybe, okay. The one is constant pressures, heating, you are giving heat, dq. Constant pressure, this state 1 to state 2. So volume change in volume. Another is, okay, this constant pressure loaded. And what is another is, write this. This is constant volume. This is constant pressure heating. Here also dq. Constant pressure heating. This is constant volume heating. So you see clearly, in constant pressure heating we are getting a work done because there is a expansion, there is a change in volume, increase in volume. So PdV involved, and that is the external work. So this is external against external work. By dt means per unit rise in temperature. For dt rise, when there is dt rise, then PdV. So for unit rise, PdV by dt. And this constant pressure is the constant pressure here. Here it is greater. Here these are absent, present. One is the PdV. Then what happens to external work is PdV. Another is intermolecular. See, when there is expansion means molecules are separated. and difficult to separate them because they have inherent attraction. So against this intermolecular attraction, this expansion, this volume change occurs. So this is actually increasing the internal energy. This is internal factor. Internal energy is what actually here? The potential form of internal energy. It is not kinetic or rotational, not kinetic in any form. Translational, rotational, vibration, no. It is potential. This is the, you will actually consider this potential energy, as I told you, which is absent in case of ideal gas. There is no attraction. So there is no internal energy increase by increase in volume. This you have seen. So, okay. So this is the thing. Okay. So two components. Okay. Two components. P. Last I told you this. P dV del T. This refers to the. So one is dW, another is du. It refers to the work done against the external pressure P. PdV, okay, work done, okay, and accordingly there is heat requirement. Follow this. Work done, why? Means now here. So for work done, there must be some heat supply. That is dQ, okay. So dQ. Extra heat is required. Compared to constant volume heating, extra heat is required because extra work is done. And another is, these gentlemen, this is about not external. Underline the external here. Del V del T at constant pressure. This refers to the internal energy. Internal energy increase. All right. Internal energy increase. Increase against the for the intermolecular attraction. Intermolecular attraction. Internal energy increase. Okay. Okay. This is refers to internal energy increase. Acha. During the internal energy increase due to the during the volume change. During the volume increase. Okay, volume increase. Actually, right here, this is the potential energy. This is the potential energy. This is the potential form of internal energy. Potential internal energy. Potential energy present due to intermolecular attraction. Due to intermolecular attraction. So both actually, now we apply the first law, you see. So this, for dW, there is some heat requirement, for du, there is some heat requirement. These are reporting here. These are present in the heating in constant pressure. In constant volume, no volume change. So no work and no question of any intermolecular attraction barrier and overcoming it and increasing the potential energy or internal energy, potential form of internal energy. No chance. Nothing here. No potential energy increase, no work done. Right? No potential energy. You write that is internal energy. Increase, no, and no work done. In case of constant volume, and these are present in case of constant pressure. This okay. This is no organ and organ in case of constant volume. In this case, in this case, in this case, in this case. These are these two present in case of constant pressure heating. These two factors terms. These two factors present in constant pressure heating. And absent in constant volume heating. Absent constant volume heating. You understand this? These are actually, so these must be giving, these two requirements must be made by the heat, dq. And Cp is about heat, and Cb also. Okay. So given this, some explanation, some idea, okay, this, let us work on this general expression further. Special case. Special case is what? Ideal gas. Acha, we will use this, we will use this later. We will use this later after the second law. After the second law, to establish second law, to establish, tell me, to establish famous relation. What is that? Tell me. Cb minus Cb. Establish the. Acha. Let me remove this unnecessary. To establish the relation Cp minus Cb is Tv alpha square by beta. So if beforehand you know this, so you will, okay, watchful about this. Okay, Cp minus Cb is okay. So we will start from this point. When I start from this point and establish. So special case is ideal gas. Ideal gas as a system. What is this? For ideal gas, an ideal gas, maybe you write an ideal gas. For an ideal gas, what is this? Del U del V at constant temperature is how much? Is internal is at constant temperature, there is no scope of any internal change. Internal solely function of temperature. For example, du is 3 by 2 RT. So ddv of 3 by 2 R2 at constant temperature is 0. So if it is 0, then what you get quickly? This leads to Cp minus Cb is P del V del T at constant pressure, and you know Pv is RT. Since it is molar, not molar, each molar means what? Molar means, you know, intensive. Use the term intensive, not avoid. Intensive property. What is the unit? Tell me. Yes. Okay, who will tell this unit? Give me, one of you. Say, you can tell you the unit Somo. What is the unit? Who came late? Some of them. Unit, Cp unit. Joule per joule. Heat required. Raise the temperature of body per unit. Heat required per unit degree. So Kelvin per mole if it is molar. If it is not molar, total drop mole. Okay, just joule per Kelvin. So joule per is right. Joule per Kelvin. Okay. So why I am emphasizing on this? That means what equation for molar? Pv is ideal gas equation. In this case, ideal gas equation of state actually. Is what? Pv is RT. Now del V del T at constant pressure is what? Del V del T at constant dV. Del V del T is, or V is RT by P. Del V del T is R by P. Happy? So substitute this is giving you is P times R by P, which gives you Cp minus Cb is R. So Cp minus Cb is R for ideal gas. For ideal gas. This actually was pending. Okay, so it is over. So let us start assignment today. Okay, I'm very sorry. Acha, whose class is next? Okay, maybe 5 minutes I'll get.
You said that.
Shout. Okay, loud.
You said that in constant volume heating decrease of the heat, there is no internal energy increase.
Uh-huh.
In constant
Very good. Potential energy. Potential form of energy.
there is no internal energy.
Have potential form that is going to be internal energy. Internal energy is 2. So right here, internal energy 2. Kinetic will be there because temperature is rising. Kinetic will be there. No one can stop. Kinetic will be there. Kinetic is a function of temperature. For a whole system, no one can stop. And temperature is increasing. Heating for what purpose? Temperature rise. And per unit rise you are measuring. Okay, happy though? Potential internal energy, potential. You see, in the first law of thermodynamics when I started, I said this potential, another is kinetic. Recall, So can I remove this? This now kinetic involves, or okay, you Amar will tell us kinetic involves which what kinetics. 3 types of kinetic translational. Now it should be no sort of different. It is so much discussed. It has been so much old. Internal energy starts. I must sit one day for 10 minutes, 20 minutes. I will learn internal energy. No, there is no point being embarrassed. All right, okay. So what is internal energy? Oh, these 3 gentlemen. But in addition, there is potential energy. So I said, external in kinetic, external potential. This ball is moving. This body is moving. External kinetic. This ball is here and lifted here. External potential energy because of the external field, gravitational. These are external. Similarly, there are internal. Internal kinetic. Molecules are actually translating, rotating, vibrating. So these are forms of life. Vibration is life. There are lives there also in the research of these inanimate things. Okay, in these materials. Okay, these matters. Okay, non-living things. As if life. So showing the science of life. Science. Okay, vibrating. Life. So internal kinetic. 3 modes and potentials are, yes, internal potential is also there, the attraction. If there are attraction, then at this distance there is some potential energy. At this distance there is different potential energy. Because attraction is there. If attraction is missing, here or here does not matter. Unchanged. This is a situation ideal gas. This is the example. No others. Real gas also attraction. Happy? Sorry. Okay, sorry. Is it? This is a bad thing I did. I'm running out of time. Running short of time. Okay, good. We'll talk. So this all over. So let us move on to first, as if first law of thermodynamics is over. So with this, no, not exactly. There is another thing that I'll discuss. That is also part of the first law. Until I start the second law, it will be the first law, under the domain of the first law. So remove, all removed. Remove. Now concentrate fully on the assignment number 2. Assignment number 2. Note, this was due yesterday. Which date it was? May 11. Acha, we could not take up. We could not take it up for want of time, and today we'll discuss this. And today we will discuss this. Problem 1. Problem 1, actually, I'll give the outline of the problem quickly. This is the outline quickly. Problem 1, what it says? This it says. Consider problem 1. Achha, I'll try to work this side will be better. This side will be better. At least you can see something. So I'll work the problem will be written that side. Problem 1 is what? Problem 1 is consider the cyclic process. Consider. Have you got a sheet or all in your mobile? Got sheet? That is good idea. Okay, that you should do. Consider the cyclic process, but all of you should have. At the end of the course, you have a good collection of things. Students after 15 years they retain this course, at least I know. They said, okay, but we have never lost a page. This preserve this. If you have to teach by who knows, then this will be valuable. Consider the cyclic process 1, 2, 3, 4, 1 undergone by 1 mole of a monatomic gas. Happy? Complete the following table. Following table. Following table. Table I am giving. Before this, let me do the 1, 2, 3 this procedure. This is your 1, 2, 3, 4. 1, 2, 3, 4. 1 to 2, 2 to 3. This is a pressure axis PV diagram. That's why you remember it is actually on the PVT surface, but projections, all projections on the PV. This I actually instructed you PV diagram. Achha, very good. V you may write in liter. V in liter. Unit careful. I repeat, careful about the unit. Atmosphere. Just assign the value. This value is given to 10 atmosphere, and this is obviously different 5, and this is correspondingly 5 liter. This is correspondingly 10 liter. This is actually, see what are the parts you clearly see. It is constant pressure and constant volume dealing, horizontal, vertical. Okay, that means there is no isothermal or adiabatic. So very easy, very good. That's why very easy. So what is the table? This is the table. Delta U. Delta U, very good. Joule, delta U in joule, all in joule actually. It's right here, joule. Delta U, joule. Delta H, joule. Write this. Q, joule. Q in joule, and W the work done. Heat interaction in joule, work interaction in joule. These 4 items you have to fill in, okay? And what are the corresponding to first step? 1 to 2, 4. 2 to 3, 4. 3 to 4, 4. All 4. And 4 to 1, all 4. Then at the end, you have to combine them to get for the cycle. What is this? Since you have to, that is also part of the table. Cycle, what is the name of the cycle? 1, 2, 3, right here. 1, 2, 3, 4, 1. This is the first cycle. The 5 items you have to complete, and for each item, 4 data to be entered. Okay, this is the job. Quickly start. Problem 1, see, start 1 to 2 step. 1 to 2 is it is actually recall, it is a constant volume process, as I see. Constant volume process. System is already described. What is the system? What is the system? No ideal gas, but still qualify it. Still, monatomic ideal gas, still, and anything else? 1 mole of. That is size. Very important. The size, that means, first of all, you try to do, let us do this, okay? State 1 is what? If you are interested. Temperature, I don't like this. You just consider that you are actually being taught by me alone. This one-to-one teaching, as if. You don't have to. Unnecessary. Okay, 1 is what? 1 state is 1, pressure 10, volume 5 liters. I am not writing then. Temperature maybe. What is the temperature? Very easily. That I don't know. It will be needed. What is the temperature? Just note. T at 1. T1 is what? You know, P1, V1 by R. Since 1 mole. NR. Actually NR, I show you. Happy? So substitute this unit. Careful about the units. P1 is what, right? Simple minded 10 atmospheres, sir. Very good, sir. Volume, sir. Volume is 5 liters, sir. 5 liters. R is it is liter atmosphere. R must be consistent. Consistent liter atmosphere unit, not joule. Here when you substituting here, it is liter atmosphere. 0.082. You know the unit is what? Liter atmosphere. Okay, per Kelvin actually, no? Mole is actually, there is mole here, 1 mole is absorbed here, so per Kelvin. So you see finally what unit you will get? Atmosphere. Mole is by mole, but it is already, here it is mole, okay, 1 mole. It has been already cancelled here. So, so what you are getting? 50 divided by 0.082. If you divide 50, have you done this? What is the result? 600? 612 kilometers, write this. 610, and see here, see, atmosphere liter, okay, so I have cancelled this, and cancel out, Kelvin is there. So what you write here, 610 Kelvin. Then you also get the other temperature out, T2, for example, before you start, T1 is this, T2 will be needed actually, T2 will be what? I am doing you systematically. What is the T2? Constant volume, okay? So T2 is what? What relation you see here? Constant volume, pressure and temperature is proportional. So P1 by T1 is P2 by T2, etc., etc. So P2 by P1 is T2 by, P1 by P2 is T1 by T2. What is P1 by P2 is what? P1 is what? 10 by 5. T1 is 610 by T2. Unknown. So it is T2 is 305 Kelvin. Kelvin. Okay. Okay. Then what happens? 305 Kelvin. Okay. So 2 down. Also quickly. How will you get quickly? Follow me. Quickly. Kelvin, second step. Quickly, this follow, this trick. It is 1 to 10 liter to 5 liter pressure down means temperature down by factor of 2. Factor of 2, pressure will be down, temperature will be down by factor of 2. Oh yes, constant, right, constant volume. Constant volume, so pressure will be 300, temperature will be reduced by factor of 2. So this is easy. Similarly, tell me without calculation. Similarly, I am writing similarly. I am giving you. Similarly, tell me. You do yourself. T3. I am writing. Say it will be 610 Kelvin. And T4 is. First T3 is what? Follow. Pressure constant. Volume is double. So temperature is double. So 610 Kelvin. You try this way, but I am giving quickly. And here volume is fixed. Pressure double 5 to 10, so temperature is also 1220 Kelvin. Happy to? Okay, so T, right, T4 is 12, this you save alongside. This will help you. This. Now start the problem. For step 1 to constant volume. What is term by term? Delta U. Delta U is what? You know, CB, NCB. Again, N I am not writing. Once I am writing, but you will understand. This is one. NCB T2 minus T1. What is CB? What is CB? Okay, what is it? CB is his name is I forget. Your name I forget. Ayushman? Ayush. CB is what? Now what's the value? 3 by 2 R. 3 by 2 R. See, molar. You see, you have to solve the problem. Molar will do what? 3 by 2 R is the answer. Closer to the answer. Closer to the solution. Helps the teacher. Helps yourself. Helps your friends. 3 by 2 R, sir. Molar means it is no answer. When you started saying molar, then I know what is your answer. Careful. Try to understand what I am asking. CB must be, why 3 by 2 R? Sukolna, why 3 by 2 R? Why not 5 by 2 R? Monatomic and CB. If it was CP, 5 by 2 R. Monatomic. Careful. 3 by 2 R. T2 minus T1. T2 minus T1, right? T2 minus T1, right? Right is what? 600, 305 minus T1, 610. Good, very good. Quickly. R is how much? Which unit you will use here? Since you have to report in joules, joule unit of R, what is 8.314? Not calorie. Neither liter atmosphere, neither cc atmosphere. No, anything. Not Pascal meter cube, nothing. So, of course, 8.314 is Pascal meter cube, but you use joule, 8.314. So, what is the answer? If you do this, I have to take help of this piece of paper. Otherwise, it will take time because all of you will. This will be helpful. Good. Minus 38. You just compare your answers. Minus 3804. Minus 3804. Is okay. So similarly, delta H is right. N Cp T2 minus T1. N is 1. Cp is 5 by 2 R as I told you, and 305 minus 610. Again you write R is 8.314. Do this, it will be actually 3 by 5, 5 by 3 times, 5 by 3 times of this, and that gives you what value? Minus 6339 joule. So you are right, all set, two things set. A joule actually, I wanted to write joule, I meant joule, but it has been. Then is the Q and W. To know, as I tell you what, Q and W, see, first law, you will always use the first law. Keep it ready. Recall, first law, keep it right at the top. Anytime and every time you will use this. Q is delta U plus W, first law. Just if required. Now I will ask you, so see, delta U is known. If you know W, for some reasons I am taking up W before Q. For some reason, that reason I will ask one of you, why I am considering W? What is the W? Value of W? Here is Sachidananda. Sachidananda W is how much? W. Now I am not asking spelling of work done. I am not asking that. What is the value of the W? So have you solved the problem? Have you solved the problem? It is whose problem? My problem or your problem? So have you solved? Problem 1. It is not 2 even. The first starting problem. So you have not solved. Have you tried? Have you tried the problems? You didn't know. What do you know on earth? What do you know on earth? Tell me. The 5 things I know. Tell me. Which things you know? On this earth you know which things? Have you read the problem? Now don't read from this backward, okay? So you should have not come. Actually, come prepared. So that you can participate. I will remove your confusion. I will solve, okay? But your participation is required. I should be satisfied that you have tried. Because I want to teach you. I have not come to teach myself. I have already solved this problem number of times, okay? So work done is PDV or such thing. Constant volume, no work, sir. No volume change. Common sense you don't have also. All gone. So work done is 0. Constant volume. What shall I do? See, any form you can PDB. See, have you noted these are all steps reversible? The way I have drawn. So reversible. Moreover, I have shown you reversible, irreversible are also same values. Okay. So write all steps. Write somewhere. Write note all steps reversible. All steps included. So work done is, see, constant volume and constant volume, constant pressure is PdV always, reversible or irreversible. So work done is 0. Then Q is what? First law, delta U plus W. Delta U is already minus 3804 joule. I am very sorry. Please write here joule. Please write here joule also missing. Unit mass, unit mass. So complete the first line. Complete the first line quickly. Complete. One done. Minus 3804 minus 6339 minus 3804 back and 0. Remember, heat interaction once more. Heat interaction is equal to what? If the question is what is the heat interaction equal to? The heat interaction between system and surrounding equal to. Someone asks you, suddenly. So what will be your answer? What will be your answer? What is the heat interaction equal to? Or which thermodynamic properties? Which thermodynamic properties? What will be Angus? Del U? No, that is not the right answer. It is just exactly equal to. It is exactly equal to what properties? That is the first law you are talking. I am not asking. I could have asked what is the first law. Okay, but that is not the answer. Okay, actually, if I give you more indication, then it will be I will give the answers actually. So what is this equal to? Your answer will be, sir, it depends. First answer, it depends. If it is a constant volume, see, just follow me. Your job is to follow me. See, if constant volume, it is equal to the internal energy change. If it is a constant pressure process, this equals to enthalpy change. Careful, no hesitation, no faltering. Then you see later, this Q is equals to some entropy change, related to entropy change later. So you will be surprised. But people actually go, what is popularly considered, Q is delta H. Okay, that is not fair. Not fair. Careful. Q is actually different. Why it is popular? Because Q is delta H actually because constant pressure process we often consider. Okay, open atmosphere process, open reactor, continuous reactor, open atmosphere often consider that. Often is one thing, and principle is another thing. Concept is another thing. Okay, general is another thing. So. Okay, what? First, so second step is what? I'm taking that also. Then I'll quit. I'll quit means I'll give the answers only. Step 2 to 3. Quick. Step 2 to 3, quickly. Please. What is this process? Constant pressure. Very good. Write that out. Constant pressure process. Very good. Then you again do delta. Take up delta U. I'll be very happy if you answer this. Delta U is what? NCV. I don't care. Like this. I don't care always for ideal gas, NCVDT. Internal energy. See, the moment it is in the domain of internal energy, an ideal gas, it is NCVDT, sir. Closing your eyes. NCVDT means NCV delta T here. Okay. So delta U is NCV. I always actually very particular about writing all terms. So don't avoid it. CV delta T. Again, what is this? 3/2 R delta T is what? Tell me. 610. That means it is actually the same value, only thing plus. R is 8. So what is this value? Plus 380. Okay, it's okay though? It's okay. Very good. Joule. Thank you. Delta H likewise same. NCP delta T likewise is actually plus 6339 joule. Very good. Q you know by virtue of constant pressure process, what is Q? What let us see, you are Nirjor or Nirjhor, Jhor or Jor, Jor. Nirjor will tell us what is Q without, okay, responsibly, yes, of the top of your head. Quick answer, Q is what? The constant pressure process. Are you not feeling good today, Nirjor? Huh? Sick, are you sick? Looks like, your eyes actually looks like, no? Okay. A moment ago, not many seconds have actually passed since then. Huh? Huh? So how long it took? That means, Anna, what do you think of yourself then? How do you rate yourself? What is this? Huh? Is it any participation in a class? Just repeat this. These things. Q is delta H. So how do you know Q is delta H? Why? Because you know. Can you prove this? Can you quickly prove? Q is delta H. Proof. Quick proof. First law. Q is delta U plus W. Repeating. Recall delta U. W is P delta V only constant pressure. PdV plus VdP. VdP out. PdV integration from delta P. PdV is actually, this is actually delta U plus delta. Give delta. Delta PV equals constant pressure. So it is delta U plus PV is delta U plus PV. See, I am showing all steps is delta H. What else I'll tell you? It is value under constant pressure. So, okay, good boy. So, same answer as delta H plus 6339 joules. What else? What else? W. W is, W you have to do. W is what you write. See, Q and delta U is known, so you not try separately. You say Q minus delta U. You do yourself and you get this result 2535. 253. Very good. Oh, some of you have solved problems. Yeah, first problems who have solved. Raise your hands. 1, 2, 3, 4, 5. Good, very good. 5 students only. What do you do, Somo? Going home? Going back home, what do you do? This is such an interesting thing. You don't like to? Rijal, what do you do? Second problem? How many have tried?
Second problem, first part. Second part is a little bit.
Second part of partly. Third problem? Fourth problem? Fifth problem? You didn't try? Third problem you didn't try? Problem 3, how many? Problem 3, how many? No one. Acha, this is okay? Can I write this? Let us insert these values. Plus 6339. Q is how much? Plus 6339 and W is 2535. Now I will not proceed further, okay? 3 to 4 you do yourself and give me the result, you check. Plus unnecessary, plus you try yourself, plus 7608, you check. Plus 126. It is better, I should not write now all the time. Plus will be implied, Plus will be implied, okay? So, okay, 12678. It is not necessary. So, plus I have removed this, 7608, 12678. Acha, well, since I'm giving, don't worry. Then what is else? Plus 7608. Then what else? What is that? 3 to 4 again, constant volume, 0. Last is 4 to 1. Back to constant pressure. Minus 7608. Minus 12678. Minus 12678. Minus 5070. You try yourself and be satisfied. 1 minute. Then cycle. What is this cycle? If you sum this, add this, you see, plus minus. Is it not very surprising? Yes, Somo, is it not very surprising that it is 0 by coincidence? Is it by coincidence 0 or what do you think? You know what? It was expected. Why?
It's a cycling process.
Huh?
So, when you evaluate state function,
Good. Catch your state function. Cyclic process, but path function will not. Soon you will see. So 0, likewise, you can close, it must be 0. If it is not 0, look back, check back your calculation. That is the idea. 0. And this will be, Q is how much I tell you, minus 2535. And this is likewise, the problem 1 is solved. Okay, solved. Right here, solved. Okay, huh? 5 over. 5 minutes? wait, okay, hang on. Is okay? Acha, tell me, see, note, here, note. You are happy, over. But, note, first law. Q is delta U plus W. Okay, for cycle, for any single step, for cycle, what you write? How you write this? Q cycle is delta U cycle. See additional note, additional comments. W cycle happy to? It's okay, huh? Now you know out of at least one you know beforehand. Before doing any calculation, this must be 0. So Q cycle must be W cycle, you see? Oh, great. Same. So minus 2535. Minus 2535 joule. Minus 2535 joule. So you are happy. But minus plus, anyone? Why minus? Do you expect minus? Can it be plus? Could it be plus in this problem? Why not? Minus. Did you expect beforehand? Yes? Clockwise or anti-clockwise? Clockwise will be positive. Is it clockwise cycle or anti-clockwise? So it must be negative. You got negative. You go, sure, one question is your over 10 marks. You will be very satisfied. So right? Note for anti-clockwise cycle, W cycle is negative, and for clockwise cycle, remember this, W cycle is positive. Now, W cycle means Q cycle. W cycle means Q cycle. Why? Because delta U cycle is ever 0. Ever. So one I have written because area. Actually. Okay. That's what we can go. Let us go ahead a little bit. I missed actually, every day I am missing class. Okay. So some 10 minutes. This over. This problem is over. Second problem. Quickly. Problem 2. Remove this. The moment he comes, Basiruddin comes, I will quit. Okay? Remove this. Problem 2.